Welcome to the next session of SHMs. So far we have learned that in case of a simple harmonic motion, force is proportional to the displacement. So the greater the displacement of the particle from its mean position, the greater is the restoring force. You know about K being a positive constant. X has been found out to be a sin omega t plus delta. Dx by dt, since x is the displacement, dx by dt can give us the velocity, and that is a omega cos omega t plus delta. Note that x has a maximum value that is equivalent to the amplitude. Only if sin omega t plus delta is equivalent to 1. It can be sin 90, it can be sin 270, sin 450, and so on. Have the radians value, you can calculate, I'm sure. Similarly, velocity will have a maximum value when this part cos omega t plus delta is equivalent to 1. One such possible case is cos 0. It can be cos 0. It can be cos 2 pi, and so on. Right? Sin and cos, these two functions repeat their maximum values on either side of the amplitude, positive and negative, after an interval of 2 pi. Okay. Now acceleration is differentiation of velocity or rate of change of velocity with respect to time, and you have minus a omega squared sin omega t plus delta. All this aside, we also came across this in the previous session, where velocity equals to omega multiplied to square root of a squared minus displacement squared. We have taken x1 as the displacement, a as the amplitude, and omega as the angular frequency. Yaad karo. Stay in touch with this formula, it will help you a lot, right? And whatever else is mentioned here, like since we discussed the maximum value of x equals to a if sin omega t plus delta equals to 1, but the minimum value of x can be 0 when if either a is 0, the amplitude is 0, or sin omega t plus delta 1 is 0. Under what conditions it can be 0? A is 0, sin omega t plus delta is 0. You know the conditions. Sin 0 is 0, sin 180 is 0, right? Sin 360 is 0, and so on. So this is all food for thought. You people know it better. The conclusion being that as long as we keep in mind that amplitude for any oscillation will remain constant, the value of x will depend upon sin omega t plus delta. And I think अभी हम लोग आगे बढ़ सकते हैं. लास्ट क्लास का रिवीजन हो गया. Let us proceed. So far we were discussing the amplitude. We checked how the derivation works out and everything. We checked velocity, we checked acceleration. Now after amplitude, one important aspect is time period. हम लोगों ने ऑलरेडी कवर कर दिया है कि एक बार ऑसिलेट होने के लिए जितना टाइम रिक्वायर्ड होता है, दैट इज़ नोन एज द टाइम पीरियड. द अमाउंट ऑफ टाइम after which the position and the velocity of the particle are repeated. That is the time period. Now, if the position is repeated, then keep that in mind. We have x equals to a sine omega t plus delta, where t is the time period, or t is the time, current time. Now, when we increase t by 1 unit time period, that means what? X will have the same value. एक ऑसिलेशन ऑनगोइंग प्रोसेस है, उसके ठीक एक टाइम पीरियड के बाद इट विल बी एट द सेम पोजिशन. ना सिंपल एग्जांपल वो सर्कल वाला, इफ़ वी रिमेंबर, एक ऑब्जेक्ट पी पे था, एक टाइम पीरियड के बाद वापस फिर पी पे आ गया. सो द पोजिशन विल रिमेन द सेम एंड सेम गोज फॉर वेलोसिटी. दैट मीन्स ए ओमेगा कॉस ओमेगा टी प्लस डेल्टा जो वेलोसिटी प्रोवाइड करेगा, जो वैल्यू प्रोवाइड करेगा, ए ओमेगा कॉस ओमेगा टी प्लस टाइम पीरियड प्लस डेल्टा वेलोसिटी का वही वैल्यू प्रोवाइड करेगा. सो इन दोनों से व्हाट वी कैन कंक्लूड इज ओमेगा टी प्लस डेल्टा मस्ट बी इक्वल टू ओमेगा टी प्लस ओमेगा capital T denotes the time period, plus delta. Now we can cancel out delta and omega t and omega t. What we figure from that is the value of sine and cos will repeat after an angle interval of 2 pi. Sine 0 equivalent to sine 2 pi equivalent to sine 4 pi and so on. Same goes for cos 0, right? So can we say that this increment of omega capital T or omega into time period is equivalent to an increment of 2 pi? मान लो sin 0, उसके बाद sin 0 plus something has the same value as sin 0. It means वो sin 0 और वो जो दूसरा साइन है उसके बीच का जो गैप है that is a multiple of 2 pi. So it is immediately after one time period that displacement and velocities are repeating. So this omega capital T must be 2 pi. From here we can obtain T equals to 2 pi by omega. बट पहले ही कहा रखा था मैंने कि ओमेगा इक्वल्स टू रूट ओवर ऑफ के बाई एम is going to be an important formula. From this we reach this equation T equals to 2 pi root over of m by k. Now this is the time period for the oscillation or for the SHM. Now keeping it very simple, there's this question. A particle of mass 200 gram executes an SHM if restoring force is due to a spring of spring constant 80 newtons per meter. Find the time period. Try finding the time period. Comment the answer below in the comment section. Also, do note that we come across the term frequency a little too often. फ्रीक्वेंसी मैच नहीं कर रहा, वाइब मैच नहीं कर रहा, ये सब आप लोग को बहुत अच्छे से पता है, कहाँ फ्रीक्वेंसी मैच कर रहा है, कहाँ वाइब मैच कर रही है, ठीक है. बट आई एम ऑल्सो श्योर you know that frequency can be obtained by inversion of the time period, right? Or frequency equals to 1 by time period. Time period क्या निकाला था यहाँ पे? 2 pi root over of m by k. So if I say 1 by 2 pi root over of m by k, I'll get what? 1 by 2 pi root over of k by m. So for this problem, you can also find the frequency, right? So try finding the time period and frequency and comment the answer below. Also try this question. A pendulum is in SHM. Acceleration of the bob of the pendulum is at 5 centimeters from mean position. So find T and F. Find time period and frequency. So the acceleration is given to be 20 meter per second square at a distance of 5 cm from the mean position. Try solving this. So I think we'll keep it at that. For the next session, we'll be having phase and phase constant.